Yes, we're continuing with our acid hydrolysis, the reaction of amides, not amines. Amines are there, but amides, we're doing amide. Here's a thing I was trying to put for you. Where is it? Let's put the thing. Here's an example of an amide. So it's going to be R, C double bond O. Then here we have an N. Remember, for us, we're doing with an NH2, but sometimes you can have an N which actually has carbons, yeah? This is still an amide, okay? Don't make no mistake, this is still an amide here, okay? So what are we going to have now when we deal with this amide? What we just want to see is this C double bond O connected to an N. That makes an amide for us. So now what happens is, if you come and do acid hydrolysis, remember for acid hydrolysis, you put water and then you can put your HCl or H2O and so forth. You can put it on the arrow. Sometimes you see them putting it like this. Make no mistake, this is still acid hydrolysis, okay? Now, what am I going to do? What happens when you do acid hydrolysis? When you put either this on the arrow or here, it's still acid hydrolysis. So it breaks here. What you must know is for hydrolysis, for amides, they break here. We saw for esters that they break between O and the carbon. Okay, between O and the carbon, this one, that is where they were breaking. Now here, they break here. That's where they always break. So now what happens is, if it's acid hydrolysis, what ions am I using? I have an H plus and an OH minus. They're the ones I'm working with. So what just happens is the H plus is going to be, remember, it's going to break like this here. It's going to break like this here. So what happens is this OH minus is the one that's going to come here, and you're going to end up having R, C double bond O, then OH, okay? Plus, this N now goes, and it's going to be N with R prime and R prime prime, which is, these are just carbons or hydrogens, whatever, depending on your amide. But then what happens is everything else that's left comes here. So for what I took these two, the H plus and the OH minus, what about here? I have an H plus and a Cl minus. Where am I going to put them? This H plus and the C. And frankly speaking, if you look here, is that, what you see is, if you look, saying frankly speaking, I mean, what you see is, this H plus is there because the OH minus is the only one that went, okay? And there's going to be this H and there's going to be this Cl. So all these three are going to come and go here, the remaining thing. So we'll put H2 and we'll put Cl. So what will end up happening is this will be a Cl minus, and this here is as an NH2, it will be a plus. Then you have a Cl minus, and these just come and you'll be having it like this. Why is it a plus? Because this carbon should be bonded, the nitrogen should be bonded to three things, but it's bonded to four. 1, 2, 3, 4, okay, which makes it a plus. Then a Cl minus will come and put itself, and they'll be bonded using ionic bonding. So it's like a plus, then you have a Cl minus. So it's going to be this plus because of the carbons that is bonded to, or the hydrogens, whatever it would have been. Okay, this is an R prime. Then that is what you'll be having. Okay, just remember that it breaks here. Then this whole consortium goes away. Now, what happens? This is for acid hydrolysis. And for base hydrolysis, let's put base hydrolysis. We love this. This is beautiful. This is the last one for amides. We only have to know this two. For base hydrolysis, okay, lysis is to break. Hydro is using water. But for base hydrolysis, we don't even put the water molecule. We just put the thing. So let's put it. It's R, C double bond O to an N. And this N is bonded to whatever. Let's put hydrogens this time. And let's say now it's going to meet your base, which is, let's put NaOH. You can also be a KOH, okay? Remember, bases are hydroxides. Remember that. Now, if you come, then what are you going to get? If it's like this, well, we know it's going to break here, okay? If it breaks here, then who comes where? Well, it's going to break here, and we are just going to have it like this. RC double bond, or like this. And then, what happens is this Na and O are the ones that are going to come here to make it an alkoxide. So this becomes an O minus Na plus, okay? Then this H that remains will go with these guys. So you'll be having plus. In this case, it would have been NH3, which is ammonia, okay? But if we had like a carbon here, which you can just say an R prime, then this would have been, you can say NH, then R prime, okay? You can put H this side and put your R prime. You could have put it like this. NH, then here is going to be your R prime, then H here. That's just what happens. So we could have put it as an NH2, NH2R, okay? You can put it as an R prime, NH2. Maybe like this, it's better. Okay? Well, depending on what was there here. So this is what happens, and you'd be done. Okay? This is just your base hydrolysis. Remember your base hydrolysis, okay? Remember it. So actually, what you'll be What you should always remember is here, these ions, and then you'll be done. Okay, here this is easier. This is very easy. I know that. So you'll be done, and these are all the reactions of your amides that you must know. Okay, and you'll be done.